minus RF over R1 times V1 plus RF over R2 times V2 plus RF over R3 times V3, depending on the number of inputs. If you had 4, there would be another one here, plus RF over R4 times V4, and that will give you a single output out, which is out 180 degrees out of phase with your input because it's all connected to the inverting input. If it was connected to the non-inverting input, your expression here would be different. Your V out would be 1 plus RF over R1 times V1 plus 1 plus RF over R2 times V2 plus 1 plus RF over R3 times V3. That is your summing amplifier. The integrator. This one is called an integrator because so far we have seen the circuits where your feedback component was a resistor, RF. With an integrator, the feedback component is a capacitor. And the output is the integral of your input. So the output is the integral of the input, that is proportional to the area under the input waveform. This circuit is useful in low-pass filters and sensor conditioning circuits. This is an integrator circuit. So your V out will be given, in this case, because the signal is connected to an inverting input, your signal will be given by minus 1 over RC, the integral of V1t dt. That will give you your output.
As she said.
And then we have a differentiator. The differentiator is like the opposite of an integrator. The major two components, they swap position. As an input, we have a capacitor, and the feedback component is your resistor. And the output, this one is used for high-pass filter circuits, integrators for low-pass filter circuits, and the integrator is used in high-pass filter circuits. And V out will be minus RC dV1 differential of input voltage. Yeah. So that covers the main categories of the circuits that you look at, because it was an inverter circuit and a non-inverting amplifier, a summing amplifier, your integrator, your differentiator, unity follower. I said unity follower, whatever you put in comes out as it is, unless that signal is connected to an inverting input. It will come out as it is, but 180 degrees out of phase with your input. That's what negative denotes. And then you have a DC offset parameters. Even when the input voltage is 0, an op-amp can have an output offset. The following can cause this offset. You have to know what attributes to DC offsets. That's when you get the signal to shift along your x-axis or along your y-axis when it's not evenly distributed above your 0. We talk of DC offset when we find that it's pushed up or pushed down. That talks to offset. And then here is a list of the possible causes of offset. It's an input offset voltage, input offset current, input offset voltage, and input offset current, input bias current. Straightforward. Okay, and then given an expression there for the input offset voltage, which is normally specified in the specification sheet of your operational amplifier. The effect of this input voltage on the output can be calculated as V offset is your input offset, R1 plus RF over R1. In this section, I'll tell you where to expect calculations. There's not much of calculations, but these are things that you just need to know. And then you have your input offset current. Okay. input bias current. You can parameter this is related to input offset current is called input bias current. Again, what offsets your current. Another important parameter here is your slew rate. Okay, it's important to know that an op-amp has a wide bandwidth compared to all other amplifiers. And the following factors affect the bandwidth of an operational amplifier, and those factors are your gain and your slew rate, which we'll soon see what we mean by slew rate. Okay. So your bandwidth talks to, this is your bandwidth. Yes, this is carrier frequency. So this spectrum here is your bandwidth. So the op-amp has high frequency response. The op-amp's high frequency response is limited by its internal circuitry. The plot shown is for an open loop gain. This means that the op-amp is operating at its highest possible gain with no feedback resistor. So it's good to know that it has a very high bandwidth, the operational amplifier, and then this is another important parameter, your slew rate. Your slew rate, which is given by this expression here, SR is delta V out over delta T, which is the maximum rate at which an op-amp can change output without distortion. Okay. The response of your output to changes in input is a ratio of how fast does your circuit detect and respond to changes into your input is what we refer to as slew rate. So delta V out over delta T is the slew rate. It's important to know this formula as well. Okay, maximum signal frequency. Slew rate determines the highest frequency of the op-amp without distortion. You know what distortion is about now. We covered that in depth in the previous sections. Absolute ratings, you find this in the specification sheets. This is what it would look like, electrical characteristics. It will tell you about its input resistance, all these important parameters, your input offset voltage. It's just good to know what it looks like. And then another important phenomenon is common mode rejection ratio, which is CMRR. Because the op-amp has two inputs, they are opposite in phase. You saw that we have a negative input, which is regarded as an inverting input, and we have a non-inverting input, which is denoted by a plus. Any signal that is common to both inputs will be cancelled. So the op-amp CMRR is a measure of the ability of the amplifier to cancel the common mode signals. Like for instance, the common mode signal is noise. Noise can be imposed by the components itself, can be imposed by wires. So in both those inputs, whether in inverting or non-inverting, noise is common. So the ability of the amplifier to reject the unwanted signal, which is noise, is what we call common mode rejection ratio. How efficient is your amplifier in rejecting that unwanted signal, which is noise? I'm noticing here that on those slides, I don't have a formula for common mode rejection ratio, but it's normally given by 20 log AD over AC. It's calculated in decibels, where AD is a differential gain and AC is a common mode gain. Differential gain, like you have differential inputs, the difference between the two inputs, like we're looking at the inverting input and the non-inverting input in our amplifiers. So the difference between those two signals is what you denote as AD, which is a differential gain, and common gain is due to the common signals, which, like I referred to on the first slide, as the signal. The signal will be, there'll be a noise imposed onto the signal. So that ratio, it's good to work it out and be in, so that you are able to see how efficient is your amplifier in rejecting the unwanted signals. Yeah, so that makes the end of this chapter. So basically there are no calculations per se expected of you, but it's important to know the different types of signals and those special features that I denoted too. Yes, I will give you a tutorial that might expose you to calculations of just a few, like an inverting amplifier and a non-inverting amplifier, as well as the summing amplifier. Definitely no calculations on the summing amplifier. You can expect calculations on those ones, on the inverting amplifier and non-inverting amplifier using this expression, and you can expect calculations on the summing amplifier. Integrator, it's good to know what it looks like, be able to draw it and be able to know its application and the expression for your output, as well as a differentiator. And that makes the end of this chapter. And then thereafter, I'll just make an announcement for what's going to be happening this week. Okay, concerning this week, it's submission of PREC report number 2 during our periods for electronics. So this means we'll meet at ASL as usual and submit the report. After submitting the report, you'll consider yourself done. And then also I will post on the group regarding collection of test number 2. The guy who's marking for me has promised to push it and try and bring it back to me latest Wednesday, but nonetheless, I will post on the group, when can you come and collect your scripts. I normally don't like just exposing it to everybody, but I'll see. I know it won't be very easy to get hold of everybody in class, because I won't be getting them like Tuesday, but I'll post on the group and tell you to come around and pick them up from me, and I'll post the memorandum as well on the group. So whatever corrections that we need to do, we'll effect them a week after this coming one. That is all concerning electronics 2. Then I have further announcements on Project 1 evaluation. I know you have seen your names. Those will be starting on Tuesday. I urge you guys to adhere to that. It's an exam. Please be there. It's an exam, and I really mean it. It's an exam. It comes natural to panic, but don't panic. It will be asking you everything that you know, which is the operation of the amplifier. So just go through the principle of operation. Just a simple explanation on what happens the moment you get your 220 volts to come in. The first component that you experience, the major component. Like for instance, like we did for our block diagram, it's just that you might have to give it a bit of detail, depending on time that will be allocating to you. Okay, so you're getting your 220 volts coming in, and it gets stepped down by a transformer. Please, when you present, remember we are talking about a particular project. So when you're explaining how a transformer works, don't say the transformer can step up or down a voltage. This is a particular project. It's doing a specific job. It's a particular transformer. So it's not about transformers in general. So be specific. This transformer will step down the voltage, and then after that, this voltage will go through the diodes, which forms a full wave bridge rectifier, where it's converted from AC to DC. Have a hang of What do you mean by rectification? Remind yourself of that, as I told you in class, that what makes the diode appropriate there as a rectifier is because of its conducting in one direction. So, okay, after rectification, you get your capacitors to filter the signal out, okay? Clipping off the peaks, so causing the signal to be much smoother. But that's not what a function of a capacitor is. A capacitor charges slowly with time and discharges slowly with time. And based on that characteristics, it makes it applicable to use it there as a filter. After a signal is being filtered, and also it's important to be able to identify the component. If I ask you to show me a transformer, show me a transformer. If I ask you to show me that bridge rectifier that you're talking about, be able to identify those diodes that are working as a full wave bridge rectifier there. Because not all the diodes, like for instance, some of you will show me the diode after the regulate. The diode after the regulator is just there to ensure the correct polarity. It's no longer rectifying. You cannot rectify and rectify again, okay? So after the signal is being filtered, it gets fed to the regulator. You have 4 regulators there. You have a 7, 8, 12. You must remember what a 7, 8 means. It's a positive 12 volt regulator, and be able to identify it also in the circuit. Okay, you have your 4 regulators which regulate to plus and minus 12 volts and plus and minus 5 volts. And then you get your output. You have your LEDs there. Be anxious to know, why do we need an LED? Remind yourself what is the function of an LED, and its name alone tells you what it does. So please remind yourself of that, and that's all we'll be asking for. Another hint there. Measure, okay. On that day, you must come on time. I've just reminded you how the circuit works. On that day, you must come on time. If you are scheduled for Tuesday at 9:15, be all there at 9:15. If your name is the last on the list, it does not mean come at 10:30. Definitely not. Please don't do that. Be all there at 9:15, because if you are all there at 9:15, we sit you and we move you fast, because we don't want our evaluation to be overlapping with other lectures. It causes you inconvenience. We don't want you to bunk classes. It's unnecessary. So please be there at 9:15. It allows us to be efficient, because if you have gaps whilst you're waiting for so-and-so who hasn't arrived, it just pushes things away, and we end up encroaching to other lectures times, which is what we don't want. So please, if you're scheduled for 9:15, be all there at 9:15. We'll give you the forms to fill in, a register to sign, so that when you come in, it all is very smooth and as quick as it can be. And also bring yourself a multimeter. Of course, the project will be coming with you. Bring yourself a multimeter, and that multimeter, make sure that you can use it. So that means you must not use it at C13 for the first time. It's a multimeter that you should have used before and you're acquainted to. And also your final report, you must bring it with you, because after you finish presentation, you leave the final report with us. Unless you really have a valid reason, we can talk about it, but you don't assume that you can just leave the venue without submitting the final report. You shall have to talk to me, and I can give you a special concession for submitting the report later. Another thing, what did I want to say? Okay, no special dress code. All I want is your head. I just want you and your head. What else did I want to say? I think I'm done. Is there any question for me regarding that? Probably prompt me with a question, then I can respond to that. Oh, okay. Yes, another thing regarding simulation. On that day, when you come into to C13, the first step, I'm just reminding you, I told you this in class. The first step, please bring your USB. You'll upload the circuit. Because of COVID, you cannot, time does not allow us to to let you guys draw the circuit from scratch. So we'll allow you to upload it from a USB, set it up. When you come to you, we evaluate the simulated circuit. Then thereafter, once we have finished evaluating the simulated circuit for the group that's inside, then we proceed with the final presentation, where we'll call you to come to us one by one, where you will be connecting the real project and doing your measurements. It's good to see. Just be anxious and exploring, because I might ask you to. Sorry, my battery is running out. Let me just quickly connect it. Okay, my battery was low. Measure your secondary voltage of a transformer. It's good. If you look at the transformer, it tells you what its input is. It tells you what its output is. It's only fair on your side to measure that output voltage of the secondary voltage, because you'll never know. I might ask it, and it's good for you to be able to know, to confirm the theory against the practical. Practical is when you measure, because that's what your learning is about. You must be able to measure that 220 volts. You must be able to measure the output of a transformer. Obviously, the output signals as well. Your +5, your -5, your +12, your -12, and also it could be nice also to see, okay, I'm getting -5, +5. Between -5 and +5, what voltage do I measure there? What is the maximum possible DC voltage that can be produced by this versatile project of mine? The name of your project is a dual power supply. I did say this in class. The word dual means two. So answer yourself, ask yourself a question, what's true about it? And answer that question to yourself, what's true about it? So it's good to carry something that you know very well. Okay, without me giving you the questions already, I think I've groomed you enough and I've prepared you enough. Panicking is natural, but please overcome it. Just do it. Just do it, because there's no way you're going to get marks without going through evaluation. So don't duck and dive and make stories and pretend to be sick and all that. No, just come, do it. Once done, you'll feel very good and it will be behind you. Any questions for me around that?
What about those who do not appear on the list, ma'am?
Okay, thank you for that question. Those who do not appear on the list, we're still busy preparing the subsequent list. The list will follow shortly. We are on it. Yeah, we are working on it. And another thing, after next week, because it's a short week, and my aim is for us to be evaluated before we go home. After next week, we'll be using almost every day, since you guys won't be in contact, we'll be online. So please make sure that this week you see when your name is appearing, and also avail yourself. If you're not on the list and you do have perfect time with such and such a group, ma'am, can I join in? You are most welcome, and you'll be offloading yourself. We'll get it behind you. So please make sure that you honor that. Don't drop the ball. Thank you for that question. Any more? Is there anyone who still hasn't collected the components? No, I take that as a no. Okay, guys, that's it. And yeah, thank you. All the best.
Ma'am,
Yes, Province.
may I ask, what's happening if you fail the evaluation? Is there any second chance?
We do give a second chance in as much as we're not supposed to be. You're talking about project, isn't it?
Yes.
Okay.
Project.
We do it out of being parents and out of being, it's just out of love. Project is a continuous evaluation subject. By its nature, it doesn't have a supplement, right? It's not like electronics. Electronics, you would fail the main exam, and if you qualify for a supplementary exam, you would go for a supplementary exam. But not with projects. With projects, it's digital. It's a 0 or a 1, fail or a pass, because it's continuous evaluation. But, well, because I happen to be a Mzali myself, I would normally give a second chance. Yes, I would normally give a second chance, but a second chance is up to your willingness. If you are willing, you approach us, we make time for you, and we do so. In as much as we are very tight time-wise this year, is very tight. It's amazing, but so I cannot promise, but that's the situation. I normally do offer that opportunity, but I cannot offer you an opportunity for a redo before I finished evaluating the whole class. So let's just hope all works well, and all the stakeholders, that is including you, hold the line, and we'll be working our hearts out with Mr. Mason, and it's just the two of us with such a large class, so it doesn't come easy, but we'll do our best to pull through. So once we're done, it's only then that we can consider people for a redo. Okay, Ndongeso, answered.